Agents and utility. A typical economic model is inhabited by one or more agents. These are idealized decision-making units whose behavior is determined by some mathematical rule. Typically, agents represent individuals, households, or firms. Firms are seen as profit maximizing, while individuals and households are seen as utility maximizing. For now, let's focus on utility. Utility is a generalized measure of satisfaction. Now, you might be thinking to yourself, wait, you can't measure satisfaction. Satisfaction has no units. That's right, you can't. So that's why utility is an ordinal measure of satisfaction rather than a cardinal one. If I say that going to the park will give me a utility of, say, 5, and having a nap will give me a utility of 15, all I've said is that I prefer napping to the park. All that matters is that one number is bigger, smaller, or the same size as another because that establishes the order of preferences. Say we have an agent, let's call him Carl. Carl can consume steaks and surgeries, and his utility is determined by what combination of those two commodities he consumes. In mathematical terms, his utility function is of two variables, steaks and surgeries. Now, if you've done some math, you might realize that Carl's utility function is going to be difficult to draw. We've got two independent variables, the amount of steaks and surgeries consumed, and one dependent variable, Carl's utility. That means that to draw this function, we need to draw it in 3D. To avoid this, we're going to take a level set of Carl's utility and draw that. This level set is called an indifference curve. Carl is indifferent between every bundle on this curve since everywhere on the curve gives the same utility value. A standard assumption to make about economic agents like Carl is that they're insatiable. That means that Carl always likes more things at least as much as he likes less things. What this means for his utility function is that it is monotonic increasing. Everything to the right of an indifference curve is higher than it, and everything to the left of an indifference curve is lower than it. And that's true for any indifference curve you could draw. Let's look at an example. Suppose Carl is offered a choice between two bundles, A and B, and each bundle has some number of surgeries and steaks for Carl to consume. If A is on a higher indifference curve than B, A is preferred to B. If A is on the same indifference curve as B, A and B are valued equally. And if A is on a lower indifference curve than B, B is preferred to A. Since Carl is a rational, utility-maximizing agent, he always does what will give him the highest utility given his constraints. So there we have it. We have a mathematical expression for Carl's behavior given his utility function and a constraint. Good job, Carl.